Hello, Algebra. Miss Stavros here, helping you with our next problem. We're going to be working on quadratic word problems. Now, I want to inform you that so far we've graphed quadratics in standard form, in vertex form, and there's actually a third method called intercept form, and I'm going to be teaching you that after this next lesson. Okay, but we're going to focus on word problems now and analyzing graphs. So we're going to go ahead and get started. I have a couple word problems I'm going to go over with you, and then there are some for homework for you to solve out on your own. Number 1 says, what goes up must come down. A mechanical device is used to launch a potato vertically into the air. The potato is launched from a platform 20 feet above the ground. So this potato is being launched 20 feet above the ground with an initial vertical velocity of 92 feet per second. Okay, it says the function h of time, so the height of the time, is negative 16 times squared plus 92 t for time plus 20 models the height of the potato over the ground in feet t seconds after the launch. For each question, be prepared to explain your reasoning. Here we go. So here's a graph. Along our x-axis, we have it time in seconds. So 0 seconds, 1, 2, 3, 4, 5, 6, 7. Along the y-axis, we have height in feet. And so I want to point out to you that it is starting here at our y-intercept. And that y-intercept would be at 20 feet above the ground. So this potato is not being launched from the ground. It's being launched 20 feet above the ground. So number 1 says, what is the height of the potato 1 second after the launch? Well, we could go over here and we could say that after 1 second for time, go up and it's approximately 100. We would be estimating at that point. So what we're going to do is we're going to take that 1 second, which represents t for time, and we're going to plug it in. H of t equals to negative 16. Everywhere you see a t, you're going to put a 1. So 1 second plus 92 times 1 plus 20. Well, 1 squared is just 1. So 1 times 1 is 1 times negative 16 is negative 16 plus 92 times 1 is 92, then plus 20. Well, I'm going to add negative 16 and 20 first. That gives me positive 4. And 4 plus 92 equals to 96. So at 1 second, the potato will be 96 feet high. So 96 feet off the ground. Off the ground at 1 second. Okay, let's go question number 2. 8 seconds after the launch, will the potato still be in the air? So now I want to go over here, go to 8 seconds. 8 seconds is right here. Is the potato still in the air? Is it above ground? The answer is no, it is not. No, the potato is not in the air after 8 seconds. I can also prove it by putting the 8 for time and seeing what our answer is. So we're going to go ahead and do that. Negative 16 times 8 squared plus 92 times 8 plus 20. Well, 8 squared is 8 times 8, which is 64. And 64 times 16 is negative 1,024. Plus 92 times 8, I'm using my side calculator here, plus 736 plus 20. When I combine all of that together, I'm going to get a negative answer. I get negative 268. So this would be below ground. Below ground. So that also proves that no, the answer is that the potato will not be in the air after 8 seconds. Next question, number 3. Will the potato reach 120 feet? When will that happen? So now I want to know at 100, I'm going to erase some of my work here. at 120 feet, which is right here, when will that happen? And that's going to happen 2 times. It's going to happen approximately 1.5 and approximately maybe 4.25. So 4.25 seconds. So I'm going to figure out exactly when will it happen. So I'm going to put the 120 feet as my height. So 120 for my height equals to negative 16t squared plus 92t plus 20. I'm going to do this because I want to know exactly when, after what t time, will it hit 120 feet. I'm going to subtract 120 on both sides, okay, because I want to set the height to, I'm going to set this to 0, and then I can solve for t. I get negative 16t squared plus 92t minus 100. Well, now that I have this, the easiest and the quickest way to do get this, I could divide each of those. Actually, I could divide each of those by 4. So I'm going to take 16 divided by 4. I'm going to get 0 equals to negative 4t squared. 92 divided by 4 is 23 plus 23t. And 100 divided by 4 is negative 25. Now I'm actually going to do the quadratic formula. Okay, so the quadratic formula is going to be x is negative b plus or minus the square root of b squared. So 23 times 23 is 529 of b squared minus 4ac. So minus 4 times negative 4 times negative 25. Well, 4 times 25 is 100. And 4 times negative 4 times 100 is negative 400. So minus 400 all over 2a, so all over negative 8. I'm going to get x is negative 23 plus or minus 529 minus 400 is 129, all divided by negative 8. So I'm actually going to take this and plug it into Desmos. Negative 28. Let's do the fraction. Negative 23 plus the square root of 129, all divided by negative 8. I get 1.45. So one answer is approximately 1.45, or I'm going to round that to 1.5. And the other one is the minus in here, so I'm going to go back up. I'm going to make that into a subtraction. I get 4.29, approximately 4.29. So I'm going to round that to 4.3. Whoops. So the potato will reach 123 or 120 feet when will that happen? At approximately 1.5 seconds and 4.3 seconds. Okay, so depending on what it's asking, height or time, we plug those values in and we solve for the other variable. When will the potato hit the ground? So when does it reach to 0? It looks like it hits the ground, the height at 0, at 6 seconds. So I'm going to make that 6 seconds, but I'm going to confirm that by doing, again, the quadratic formula. So I'm going to put negative 16 t squared. Our equation is plus 92t plus 20. I want to know when will it hit 0. Now, by the way, only hitting 0 one time because it started at 20 feet off the ground. Again, I can divide all of those by 4, and it's going to make it a little bit easier, smaller numbers to work with. So that's going to give me negative 4t squared plus 92 divided by 4 is 23t plus 5. And I'm going to do the quadratic formula with this one. X is negative b plus or minus the square root of b squared. B squared is 529 minus 4ac. So 4 times 5 is 80. So we're going to actually plus 80 on this one because -4 times -4 gives you a plus all over 2a. Okay, so I'm going to do -23 plus or minus the square root 529 plus 80 is 609, all divided by -8. So -23 plus the square root of 609, -23 plus the square root of, what was the value? 609. All divided by -8. I can't have a negative in there, so I know this is going to be a minus in there. I get 5.95, which we're going to round to, which is approximately 5.95, which I'm going to approximate to being 6 seconds. And that's what our picture also shows us, is about 6 seconds. Okay, question number 1 is done. Let's take a look at question number 2. The revenue from a youth league baseball game depends on the price per ticket X. Here is a graph that represents the revenue function R. So again, we're comparing along the x-axis the ticket prices in dollars, and along the y-axis the revenue, the dollars that we made after tickets were sold. It says select all true statements. So the revenue when 5 tickets is purchased, letter A, is a little more than $600. Let's see here. So I want to know when 5 tickets are purchased, the revenue is a little bit more than $600. I would say that that is a true statement. Letter B, the revenue for 600 tickets, the revenue is $600 for a little less than 5. So a little less than 5 anywhere in this zone is a little less than 5. Let me go back on that one. The revenue is 600 for a little less than 5 tickets. That's false. False, not true. The revenue is more than 5 tickets. Letter C, the maximum possible ticket price is $15. So is this the maximum ticket price? No, that's the maximum number of dollars being made. The maximum ticket price is actually going to be $30. So C is not correct. Letter D, the maximum possible revenue is about $1,125. So let's go back over here. Let's see, that's the maximum revenue is about $1,125. I would say yes, this one is correct. Okay, let's go to the next one. The next one is, if the tickets cost $10, the predicted revenue is $1,000. So if the ticket, I'm going to change my color. If the ticket is $10, the revenue would be $1,000. Yes, that would be correct. And letter F, if the tickets cost $20, the predicted revenue is $1,000. If the tickets cost $20, so let me erase some of this work here. If the tickets is $20, the predicted revenue is $1,000. I would say yes, that is correct. Okay, so I used my graph to help me on this one. Let's go to number 3. A garden designer designed a square decorative pool. The pool is surrounded by a walkway. On 2 opposite sides of the pool, the walkway is 8 feet. On the other 2 opposite sides, the walkway is 10 feet. The final design for the pool and walkway covers a total area of 1,440 square feet. The side length of the square pool is, this was a typo, is X. Write an expression that represents the total length of the rectangle, including the pool and the walkway. So the length is going to be the long side. So we know that this pool is X, and we know that this space right here is 10, and this space right here is 10. So the length of that pool is actually x plus 10 or x plus 20. Okay. Now let's go ahead and do the total width of that rectangular pool. The width of the rectangle pool, again, we want this length right here. Well, I know this length to this length, the pool is x, and the side lengths for the walkway is 8 each. So the width of the pool would be x plus 8 or x plus 16. And now I want to know an expression that represents the total area of the pool and the walkway. Well, the total area is 1,440 square foot is our length times width. Our length is x plus 20, and our width is x plus 16. All right, algebra number 3 is done. Let's go ahead and look at question number 4. We're talking about football here. A football is kicked up from the ground level at an initial upward velocity of 90 feet per second. The equation h is negative 16t squared plus 90t gives the height h of the football after t seconds. What is the height of the ball after 1 second? So I want to know after 1 second, so our t equals to 1. So I'm going to take my equation, h equals to negative 16, and I'm going to put 1 in wherever we see the t for time, plus 90 times 90 times 1. H is negative 16 times 1 squared, which is 1, and 90 times 1 is 90. Negative 16 times 1 is negative 16, and negative 16 plus 90 is 74. So the height is 74 feet after 1 second. Okay, the question is now asking, when is the ball 126 feet high? Let me shrink some of this work down. Okay, now I want to know when. So I want to know for time. When will it be 126 with height equals to negative 16 t squared plus 90 t. I want to solve for t, so I'm going to set my equation to 0. So I get negative 16 t squared plus 90 t minus 126. I believe I can divide those each by 4. Let me double check here. 90 divided by 4. Nope, I can't. I can divide those each by 2 though. Negative 8t squared plus 45t minus 63 equals to 0. Okay, I'm going to use the quadratic formula for this one because I want to solve for x, or t, I shall say. T is negative b, negative 45, plus or minus the square root of 45 squared is 2,025, minus 4ac, so minus 4 times negative 8 times negative 63. So 4 times 8 times 63 minus 2016 all over 2a. So time is negative 45 plus or minus 2025 minus 2016 is the square root of 9, which is 3, all divided by negative 16. Okay, so now I'm going to do 2 questions here. Negative 45 plus 3 divided by negative 16, and negative 45 minus 3 divided by negative 16. So I'm going to get 45 minus 3 is 42 divided by negative 16, negative 42. When I divide that, I get approximately, I'm going to round it to the 10th, 2.6. And 45 minus 3 is negative 48. Negative 48 divided by negative 16 equals to positive 3. So when will the ball be 126 feet tall? At approximately 2.6 seconds and 3 seconds. All right, let's move on to question letter C. It says, when is the height of the ball 0 feet? So I want to know, when will the ball hit 0 feet, which is the ground? So there's going to be 2 points here. number one, before the ball is hit, it's at the ground. And number two, when after the ball's hit and it drops to the ground. So we want to figure out when will that happen. So I'm going to substitute 0 for height. So 0 equals to negative 16t squared plus 90t. And I know I can actually solve by factoring out. I'm going to factor out a t from both sides. So I get t times negative 16t plus 90. And now I have two answers. T can be 0 and t can be negative 16t plus 90 equals to 0. So I get negative 16t equals to negative 90 because I'm going to get t alone. I'm going to divide by negative 16 on both sides. Whoops, negative 16. And 90 divided by 16, it's going to be a positive here, is approximately 5.625 seconds. I'm going to round that to 5.6 seconds. So the ball hits the ground at 0 seconds and 5.6 seconds. Alrighty, algebra, I hope you're doing well. Don't forget, you do not have to do question number 5 on the notes. That is optional. And then you have your homework at the bottom of this page. I hope you're doing well, taking care of yourself and your family. Send me a message if you have any questions.